I just had one of the best sneezes I've had for a long time. Okay, I am going on a walk, and I brought my phone so that I can share my thoughts. Okay. Ooh, that was a good sneeze. All right. I was thinking about, well, I can't find any water here. I was thinking about just the idea of a wave on water, and it kind of proved something to me a little bit about the surface of water. There's like waves, there's like swell, where it kind of goes up, down. That's really what a wave is. It's like where part of the water goes up. That part that's up obviously needs to be missing from the part that's down. And what am I talking about? Up or down from what? From a straight line. A flat, straight, not curving line. Now, when we look over water at things, we see a lot of optical illusions. And those optical illusions have become answers for people to questions that really can't be answered. So it's actually more of a belief. Someone says, well, the water curves. It's just we're so small and the earth's so big. They say the water curves. You just can't see it. Well, you can see it if a boat's going over the horizon. They think you can see curvature of the earth, and that happens pretty close, like not very many miles, that a ship will appear to sink down a little bit. But that's just perception. That's how we interpret what we see, or how we have. But there's a different way to interpret it that makes, if you ask me, it makes way more sense. But a wave, even like a sound wave, like sound, there's an up part and a down part. I'm at Home Depot in the parking lot, so I'm just walking around. I'm in New Jersey, flying back to Minnesota in like 2-3 hours. So I'm making a video. If the plane crashes, this might be my last video. But when you have still water, it's with no waves, if there was such a thing, but because there's always going to be a little bit of movement of the water, I think. But if you had perfectly still water, the surface of it's going to be perfectly flat. And it has to be, like, fundamentally has to be, if we actually think about, forget the fluid dynamics and the study of what water does, and just think of the basic principle. I'm actually going back. I don't need to get anything at Home Depot anyway. I actually just wanted to go on a walk. But when you have a wave, like, let's say you have a pool of water and it's still. If you were to drop a golf ball in the middle of that pool, you're going to get a wave pattern. We all know how this works. The rock going down, obviously, well, technically it adds to the volume of whatever container that water's in. A little bit, it adds its own size to that or whatever. But when it does that, some of the water gets pushed down by the ball, and the water around it goes out to get out of the way, and it creates a wave. It creates a wave in like a ring, and it's going to move away from the point where it started in all directions. And I'm no teacher about water, but I'm an observer of it, just like you are. So what's really happening when there's flat, still surface of water? And here's the thing, if you think you see the water curving in front of you at the ocean because you're seeing the tops of ships last, you're not. You need to estimate how far away that ship is and how far away that curve is in front of you. What is it, 5, 6 miles, maybe even 10, 12? What is it? Because if you're, let's do this mind exercise. So I'm gonna turn the camera around. Okay, we're looking at, actually I'll get those white stripes and that'll help, okay? We're looking at that. Let me get centered on those things. How do I do that? Okay, there we go. Sorry, I'm holding it backwards. Okay, so we're looking that direction. The things in the sky and the things on the ground end up converging somewhere. But here's the thing. If I can look and see curvature, you know, say directly in front of us or whatever, and that's only 5 or 6 miles, how far do you think I can see if we turn all the way to the left, look as far as you can see, then turn all the way to the right and look as far as you can see? That's many more miles than that short distance between you and that ship in front of you that you're thinking you're seeing the Earth curvature. So I think I'm not saying it's a bad way to look at it, because I think we've all looked at it that way. But there's a better way to look at it, and that's just why my mind is just going through the idea of a wave. There's only so much water in the pool or in the whatever, the container. There's only so much water in there, and if you push some of it down, some of it has to come up, because you can't really compress water. You can't make it smaller than it is. I mean, we could convert it to steam or something. I'm talking about liquid form, water. It has it's everywhere on this earth. It's all over the place. And that just brings up another thing. If water is flat at its surface, and it's as part of reality, it needs to be. It has to be flat at its surface. And even if you go, let's just say, I'm in Minnesota, so let's just say I went to South America. Am I going to be relative where I'm at right now? The ground is flat. The sky is above me. If I go around that curvature past the equator, down and stand on South America on the bottom side of the globe, am I nearly upside down relative to where I am right now? Yes. How do you know though? You never experienced that. That's an idea that we can't prove, okay? Here's the deal. You have a circle. We can do it with geometry. We don't even have to use a sphere, but the Earth is, the circumference of it is 24,900 miles, right? So you're going to get in your car and you're going to drive around the globe or fly around the globe or whatever. It'd be close to 25,000 miles, okay? So 360 degrees, right? Because every day the globe would rotate one time, right? So you'd have the globe going like this one time. And if we take 360 degrees and we divide that up evenly in that 24,901 miles, we end up with every time we travel, like let's say I'm standing here, if I travel 69 miles, then relative to here, I'm 1 degree off. So every 69 miles, you're going to go another degree different from your relative position that you were at when you started the 69 miles. But during all of that, during all of your travels everywhere on the globe, do make note that the sky's always above you and the earth is always beneath you and that water is always flat. You don't have to believe that the whole earth is flat, but it sure makes sense, doesn't it? What happens to water if we have a bucket of water and we drill a hole in the bottom of the bucket of water? Where does the water go? It goes out of the bucket. Why? Gravity. No. That's an idea. Maybe it's right. But no. I'm looking for like the actually correct answer, the one that actually would be an honest and acceptable answer to a question like that. Why does the water go out of the bucket? How about, why do you breathe air? Why is it air that you breathe? Why do people have 2 nostrils? Why do people go bald when they get old? Or I was like 20 when I started going bald. What is this life? That's what kind of question you're trying to ask. If you're asking why something falls to the ground at 9.32 or meters per second squared or whatever it is. That's an observation we make. Here, look. Got a rock. We can measure that, right? We can measure that. We can observe it falling. But you know as well as I do that you can't tell me, and I can't tell you, what is the reason that happens. And my best answer to that would be, you might have a different answer, but here's mine. That's part of the reality we live in. That's my answer. We make the observation of things falling and we can try to put math to it and make sense of it. But that still doesn't mean you know what is going on when something's falling or whatever. Density, buoyancy, gravity, electric or electromagnetism or what. Like, there's a lot of things that we know about. But yeah, when you have a surface of water, you have like a constant volume. It's not you're not pouring water into it, which really wouldn't change it much. But when you splash something into it, the water goes down. And it needs, basically it's displaced. That's where the wave comes in. Otherwise, it's perfectly flat if it's still. Not curved. Not level, curved level like your level that you would use to build a house or to build anything, really. All right, so it's not even a debate. I think that water must be flat when it's still. And it also has to be in a container. It has to have a shore or you know, the sides of a cup. It can't just be water standing out. It doesn't take shapes like that. Crows, they sound sick though. All right, guys. Have a good day.